Welcome to this explainer. Okay, today we're diving into something that is frankly borderline reality breaking. We are looking at this incredibly fascinating concept of using formal computer code to actually prove the mathematical limits of the universe. I mean, just pause and think about the historical weight of that for a second, right? For thousands of years, humanity mapped the stars with astrolabes, then we upgraded to these massive optical lenses, and more recently, staggering arrays of radio telescopes that capture invisible frequencies. But today, well, today we're essentially trying to compile the universe's source code. The whole idea here is that we can literally map the infinite, or actually to be more precise, we can rigorously prove whether an actual infinity can even exist in our physical reality. And we're doing it using the uncompromising, hyper-precise language of computational logic. It's this absolutely profound intersection of computer science, deep philosophy, and cosmology. It totally shifts our relationship with the cosmos, taking these super abstract physics concepts and turning them into undeniable, hard-coded law. So the massive, mind-bending question we are tackling today is just this. Can we write computer code to prove the limits of the universe? For decades, we've been looking up at the night sky, using theoretical physics to basically make really good, educated guesses at the shape, the edges, and the age of everything. But what actually happens when we take those massive cosmological claims and feed them into rigorous theorem-proving software? Can we find the actual operational logic of reality? And maybe more importantly, can we figure out exactly where that logic simply runs out of memory? Honestly, when you really start thinking about it, it almost makes you wonder if we're living in a cosmic simulation that's just going to throw a blue screen of death or a Stack Overflow error if we try to look too far past the rendered boundaries. It is an incredibly audacious goal, to force the entire universe into a compiler and just see if it passes the test.
To actually pull this off, we have to define the core tool at the absolute center of this project, and that is computational logic. In the context of the material we're unpacking today, this means using formal computer code and mathematical proofs to verify complex truths about logic and the cosmos. Specifically, they're using advanced tools like the Lean theorem prover. And we really need to pause here for a second to understand what Lean actually is. Because Lean isn't just some fancy calculator. Not at all. It is a rigorously strict programming environment where a mathematical proof literally is a computer program. So if the logic of your cosmic theory has even a single flaw, this one unverified assumption, or one tiny contradiction, the code fundamentally will not compile. It just stops cold. It rejects the universe you built. It forces this utter, undeniable honesty upon our physical theories, stripping away all that hand-waving that sometimes happens in theoretical physics and completely replacing it with unforgiving computational law.
Okay, to make sense of this massive mapping project, here is our quick roadmap for today. First, we'll look at the limits of logic itself. Second, how we anchor the math. Third, how this code actually bounds the universe. Fourth, we'll trace the epochs of cosmic expansion. And finally, we'll look at the actual geometric shape of reality. Let's get into it. Section 1. The limits of logic. Specifically, the failure trilemma and Gödel. Before we can even attempt to map the physical universe, we actually have to grapple with the boundaries of human knowledge itself. Specifically, we have to address something called the failure trilemma. Now, in computer science and advanced mathematics, there's this legendary foundational roadblock established by Kurt Gödel with his incompleteness theorems. In simple terms, Gödel basically proved that any formal mathematical system that is sufficiently complex is inevitably going to contain statements that are true but fundamentally unprovable within that system. It absolutely ruins a mathematician's day, right? Because it means the system is inherently incomplete. It cannot prove its own consistency without breaking down. And the authors of this cosmic model, writing in code files like Arrow-Gödel consciousness, they directly acknowledge this. They admit that their proof automation has what they call a broken surface. They know they're hitting the fundamental limits of formal systems, where certain macro views of knowledge just simply failed to compute perfectly. They can't prove everything automatically, because the very fabric of logic has blind spots built right into it. And honestly, that's a profound starting point. Just admitting up front that the logic we are using to map the universe is, by definition, fractured.
Which brings us to Section 2, anchoring the math with verified rustic church markers.
So, if logic itself has these inherent holes and broken surfaces, how on earth do computer scientists fight against that incomplete logic to map the universe anyway? Well, they do it by building these undeniable mathematical outposts. This is perfectly demonstrated by the architecture surrounding files like Aeon Flux site adequacy. Because the overarching universe model relies on incredibly complex, really heavy proof automation that might sit completely outside this highly restrictive code package, the programmers can't always trust the macro system. So they have to leave behind what they beautifully term verified rustic church markers. I just love that phrase. Think of these like small stone cairns left behind by ancient explorers in this vast, uncharted, terrifying wilderness. When the complex automated systems inevitably fail, or when the entire digital architecture is being rebuilt from scratch, these markers serve as simple, undeniable beacons of truth. They essentially tell the surrounding system, hey, yes, despite all the chaos and the incompleteness of the higher logic, we are still grounded in this undeniable pocket of reality right here.
And the sheer contrast to this is actually almost funny when you really think about it. Imagine mapping the multidimensional edge of infinity, projecting the absolute limits of time and space, but being so utterly terrified of your foundational logic collapsing under the weight of Goala's incompleteness that you basically have to write a sticky note for your supercomputer to remind it that 1 + 2 = 2 + 1. Because that is the theorem n + m = m + n. It's literally just basic commutative addition. Yet, in the Noble Universe Map code, this incredibly simple piece of math is acting as a verified rustic church marker. It is the absolute unshakable bedrock. You are anchoring your incomprehensibly vast, multidimensional mapping software to the undeniable truth of toddler-level arithmetic simply because it's the only way to keep the overarching cosmic simulation mathematically honest and prevent the whole thing from spiraling into paradox.
Moving on to Section 3, Bounding the Universe. Effective versus total expansion.
Now we take those logic ledgers, those anchors we just talked about, and we apply them directly to the physical size of the cosmos. And this happens through the Observable Universe Finite code. This file is absolutely critical to the whole project, because it states what the authors call an honest finitude claim about our universe. But what exactly makes a claim honest in the realm of computational logic? It means there is absolutely zero mathematical hand-waving going on. There's no assumed infinity just because space looks really, really big to us. Instead, the code acts as the strictest, most ruthless auditor possible. It forces the model to mathematically declare, without a shadow of a doubt, whether the volume of space we can observe goes on forever or if it hits a hard, mathematically verified wall. So an honest finitude claim means the software has checked every single variable and compiled successfully only because the limits of the space are definitively, provably locked down.
To really grasp the magnitude of this, we need to make a very careful, highly philosophical distinction that's established deep within the source text. There's the observable, or the effective universe, and then there is the total expansion of the universe. The code is directly bounding the effective universe with strictly finite limits. But, and this is a huge but, the source module explicitly states it does not claim unrestricted finitude for every possible total cosmic extension. The universe, in its absolute totality outside of our observable reach, well, it might expand indefinitely into sheer, unrestricted possibility. It might be terrifyingly endless. But the effective universe, the reality that we can actually map, name, interact with, and observe, that is treated entirely differently by the logic. It is tightly quarantined away from that outer infinity.
Which brings us to one of the most profound questions in human history. If you go outside tonight, look up at the night sky, and point a telescope into the absolute deepest blackness, does it go on forever? Or does it eventually hit a mathematical brick wall? We are now basically subjecting that exact philosophical question to the absolute strictest standards of theorem-proving code. Does the sheer volume of what we can effectively interact with simply never, ever end?
Well, the answer, according to the strict compiling logic of the Observable Universe Finite module, is a resounding, verifiable no. The code expressly states that, quote, all named observable epochs are bounded by one finite ceiling. Let's really break down what a finite ceiling actually means here, because it's not like a physical glass dome surrounding the galaxies. Think of it more as a computational, numerical limit to the amount of information, physical volume, and spatial extension that can mathematically exist within our effectively mapped reality. The code proves that the effective universe simply cannot exceed this numerical limit. It is an honest, verified hard stop. Our observable reality is definitively not an actual infinity in this model.
Section 4. Epochs of Expansion, Tracing the Cosmic Timeline.
To prove this finite ceiling isn't just a wild guess, the source code actually traces specific stages of cosmic time, locking them down chronologically on a timeline. The code defines a strict inductive type called observable epoch, complete with very specific variables mapping out the universe's growth. It starts at a baseline anchor epoch called 1 Lorenzo, which is the code's designated foundational starting point. From there, we move to the epoch named now, which is exactly what it sounds like, the exact mathematical slice of time where we currently exist. Then, the timeline advances using geometric growth models, stepping forward to an epoch designated phi squared, and then pushing even further out to phi cubed. And these aren't just random names. They represent strict, mathematically scaling stages of cosmic expansion, measured in microbillions of light-years. The code painstakingly calculates the observable volume at each of these specific named epochs, and the compiler verifies that every single one of these stages, no matter how massively they mathematically scale up, remains fundamentally finite, eventually smashing right into the final variable, the ceiling.
All of these epochs, every single stage, culminates in one deeply important mathematical theorem, variable, cosmic projection.max observable. This specific number acts as an unbreakable cage for time and space within the system. The Lean software executes a rigorous proof demonstrating that the size of the universe in the now epoch is strictly less than this max observable boundary. But it actually goes further than that. Even the vastly expanded future sizes at phi squared and phi cubed are proven to be strictly less than this ultimate limit. The logic physically and computationally will not allow the observable timeline to breach this numerical boundary under any circumstances whatsoever. The cage holds.
Section 5. The shape of reality, dimensions, and toruses.
So if we live in a rigorously bounded, entirely finite observable universe, what does this bounded space actually look like geometrically? Well, this is where the topological math gets absolutely incredible. According to the Universe Shape by Dimension file, there's a very specific sequence. Step 1 introduces the Wallington dimension rule, which is this off-by-1 law written structurally as stages equal stages plus 1. Then, Step 2 explains the massive topological consequence of that rule. Any visible ambient surface in d dimensions is carried by a torus of d-1 dimensions. Therefore, in Step 3, if we take our standard three-dimensional visible slice of reality, we apply that off-by-1 rule, we subtract 1, and the code mathematically dictates that our reality is fundamentally a 2 torus. Yeah, you heard that correctly. According to the most rigorous, unforgiving mathematical logic software on planet Earth, our 3D observable volume curves back on itself to form a giant, multidimensional donut. Homer Simpson would be absolutely thrilled. The math implies that space isn't just a box, it wraps and connects in a highly specific, verifiable topological geometry.
But the Lean module is incredibly careful to keep this donut-shaped claim completely honest. It warns us that this shape isn't some universally frozen constant for all of existence forever. The text explicitly points out that higher ambient dimensions lift the torus rank instead of freezing it. Just take a second to let your brain melt around that concept. It means that if reality actually operates in a 4-dimensional or a 5-dimensional ambient space, the topological geometry shifts and complexifies drastically. The 2 torus, our giant cosmic donut, is specifically the shape of a 3D visible slice, derived precisely from that off-by-1 mathematical law. If the dimensions scale up, the geometry of the universe morphs into these higher-order topological shapes that are almost impossible for the human brain to even visualize. But they are perfectly easy for the compiler to verify.
And how exactly do the authors secure these wildly complex dimensional towers in the code? Think about it. We are talking about mathematically plotting multidimensional, shifting toruses and rigid cosmic ceilings. Yet in the Universe Tower file, which manages all the structural stubs across these massive dimensional realities, the mathematical theorem securing the entire namespace, the structural witness keeping it all mathematically valid, is simply 1 + 1 = 2. It is a beautiful, almost poetic irony. Even the absolute most advanced, brain-bending topological maps of human reality must fundamentally rely on a toddler's math equation to ensure the complex proofs remain grounded. If 1 + 1 doesn't equal 2, the entire multidimensional torus unravels.
Throughout these source files, we repeatedly encounter variations of this deeply moving statement, recorded as a verified rustic church marker until the full init-only formalization is rebuilt. It just perfectly encapsulates the sheer frailty of human knowledge. In a vast, potentially incomplete digital system where complex logic can fracture and where automated proofs of the cosmos can so easily fail under the weight of Gödel's theorems, these simple bits of code act as our unshakable life rafts. They are beacons of knowable truth in a massive sea of computational uncertainty. They are the humble, desperately protected foundations keeping the grand, terrifying map of the cosmos from collapsing entirely into paradox.
Which really brings us to a truly breathtaking final realization. Our observable 3D reality, exactly as mathematically mapped and proven by computational logic, acts as a finite 2 torus. It is strictly bounded by an unbreakable numerical ceiling. The software guarantees this finitude. It successfully compiles. But remember, the logic explicitly does not restrict the total universe.
The outside remains totally undefined, so we are just left to sit with this thought. If our entire mapped, knowable reality is just a bounded, donut-shaped pocket of space anchored by the fact that 1 + 1 = 2, what exactly lies in the indefinite, unrestricted expansion beyond our ledger's reach? Thank you for taking this incredible deep dive into the intersection of code and cosmology with me in this explainer. Keep questioning the very limits of your reality.